Hello, welcome back. I'm Abdallah Reda. We are still in the differential calculus in the limits part. And today we'll talk about the limit of a function to infinity but at first we must have an example to show what does this term mean. So if I write fx equals 2x negative 3 over x plus 1, and I want to get fx when f equals 9, f equals 99, equals 999, and f 9999. Well, if you try it, you will have the results that look like this. F9 will equal 1.5. F99 equals 1.95. And if 999 equals 1.995, and f of 9999 gives you 1.9995. Well, as this number increases, if x approaches this value, which would increase gradually till it reaches 2, because if we approximate all our results, we will have a 2. So we can write this term in another way. Instead of increasing our substitutions with the x, we can write fx approaches 2 at fx equals 2x negative 3 over x plus 1. Alright, then how would the fx approach the value 2? We said that when we increase the value of our substitutions of the x in the equation of the fx, the value of fx approaches 2. So as we increase the value of x, it means that x is approaching infinity. So that's what our term means, the limit of a function to infinity. As f approaches infinity, the fx will approach the 2. Alright, we learned before to substitute with a value which x approaches directly in the equation to get the answer. So let's try it. If we say that the limit x approaches infinity, fx equals lim x approaches infinity 2 by infinity negative 3 over infinity plus 1, so it yields infinity over infinity, and this value of course is undefined, so this is not the correct answer. So how could we get the answer in this situation? There is a rule used here in this form when you have the limit of a function to infinity. Our rule says that when we have the limit x approaches infinity 1 over x, it equals 0. So, and of course, we know that any value divided by itself equals 1. So we can use x over x equals 1 and lim x approaches infinity of 1 over x equals 0. Those are two very important rules here in our lesson. So let's see how could we solve this problem. Alright, so we will write lim x approaches infinity, and here 2x negative 3 over x plus 1. So we will divide the numerator and the denominator by x. We'll divide both of them by x. And of course, this wouldn't affect our answer because x over x equal 1, as if you have divided the equation by 1, so the answer wouldn't be changed. Alright, here we have lim x approaches infinity. So here we have 2x over x, negative 3 over x, over x over x plus 1 over x. So this is the shape of our problem. Of course, this will go with this and this also. And here, this would give us a 0. And this also would give us a 0. Any term over the x, when x approaches infinity, gives us a 0. So the answer will be 2 over 1 to give us a 2, which is the right value that fx approaches when x approaches infinity. So this was the beginning of our lesson. This was a problem to illustrate what is the meaning of the x approaching to infinity. And the next time we will have more examples on this lesson. And that's it for today. See you next time. Thanks for watching.